Hi guys, in this video I will explain some important experiment of MC physics. If you are doing MC physics or BSc or BSc Honors physics, then these experiments are important for you. Let me discuss this experiment. I will discuss this experiment by using the apparatus and show you how to use the apparatus. Okay, so these are experiments. So these are experiment I will discuss. The first experiment I will discuss is band gap. In this experiment, I have to determine the band gap of a semiconductor using the junction diode. And the second experiment is Planck constant. I will find the Planck constant by photocell, and then I will determine the charge to mass ratio by using the magnetron method. And then the fourth experiment, Young modulus. In this experiment, I will find Young modulus and Poisson's ratio of a glass by method of Cornus. And in the fifth experiment, Cauchy constant, I will find the Cauchy constant A and B. Okay, then I will do sixth experiment, GM counter, characteristic of GM counter. And in this experiment I have to study the variation of a counter with the applied voltage, and thereby I will determine the plateau, operating point, and the slope of the plateau. Okay, and in the last seventh experiment, Frank Hughes experiment. This experiment is very important. In this experiment I will determine the electron occupy only the discrete quantized energy state for a orgon atom. So I will verify this. So now let discuss this experiment. So this is an experiment of band gap apparatus. Now in this experiment you can understand the band gap by, as a name suggests, by the name you can understand the meaning of band gap. This is the gap of bands, conduction band and the valence band, and it is a difference of the energy of it can be defined as a difference of energy of band gap and conduction band. So this is the apparatus. This is the apparatus to find the band gap. Here I will find the band gap of germanium. The value of the band gap of germanium, standard value is 0.7, around 0.7 electron volt. So you can see the circuit diagram of this apparatus here. This is a 3 volt DC supply. This is the ammeter of 50 microampere. Here we use oven. This is a thermometer we use. Okay, now we switch on. After switch on, you can see the temperature of in this thermometer. You can see increasing. It will increase up to around 89 or 90 degrees Celsius, and when the current is passed through this ammeter, the value of current you can see here increasing in microampere. So we have to wait for around 10 minutes for reaching the value of this up to around 90 ampere. Okay, so this will be the reading for this experiment. When we after reaching the value of the temperature in the thermometer around 90 degrees Celsius, then we switch off this button and note down the reading of temperature versus the current in microampere. Like here you can see in this table, note down the value of the IC for every 10 or 5 difference in current and corresponding value of temperature. Okay, so and then make a graph. I make here a graph. So the slope will give you this value, and by measuring the slope you can find the band gap. Here I use this formula del E is equal to slope of line upon 5.036, and the value I get is 0.58 electron volt, and the standard value is 0.72, so I get this percentage error. So this is the experiment to measure the band gap. This is the apparatus for finding the E by M specific charge ratio. Okay, so in this experiment, I done this experiment. We use this formula: E by M is equal to 8V by Hc square Ra square. Here Va is the anode potential we measure from this. Okay, we have to fix this value. Okay, Sc is the critical magnetic field, Ic is critical current, cos theta is the fixed value 0.7388, and Sc is equal to 4 pi n Ic by 10. Here n is the number of turn per centimeter. So the value of n, Ra are fixed. You can see here. Okay, now we have to plot the graph between anode current and solenoid current, means this versus this. Okay, for a fixed value of Vp, anode potential. Suppose here I take 5 volt, here I fix it at 5 volt, then I have to vary this versus this. So when I vary the reading of mu current, yeah, we get this value. Now when we decrease the value of current, we get this change in this manner, the change in anode current and in change in Ic in this manner, and we note down the reading. We get table for this like this. Okay, so we use these things for 3 times for different value of Vp. Like here you can see, and graph for these 3. So the point where the slope is changing is the point where the current is the critical value of current, which is known as Ic, where here we use Ic. Okay, so the value of Ic for these 3 different graphs is different. Here 0.55, for this 0.6, for this 0.6, and now we put these values in Sc and we calculate the E by M. This V is Vp, anode potential, which we fix for the 3 different graph. We get E by M for every Vp, 3 different value of E by M. The circuit diagram you can see here for this experiment in apparatus. So we get the value, the mean value of E by M 1.6 into 10 to the power 7 EMU per gram, and the standard value is 1.6 into 10 to the power 7. So we get percentage error 22.4. This is the experiment to find the E by M specific charge. Sorry, I forgot to tell one thing. In this experiment, we have to fix the apparatus in a east-west direction. Okay, so this direction is east and this is west, this is east, this is west, then we have to fix it here. Okay, so that we can get better result.
बता देना कब स्टार्ट करना है।
स्टार्ट है।